In today's episode, a ghost has arrived on the moon, Athena is preparing for touchdown, and an issue has emerged with SpaceX's Starship. For the first time in many decades, a spacecraft manufactured in America has landed safely and successfully on the lunar surface. And as sunlight spreads across the moon, the Blue Ghost lander's mission has already commenced. Blue Ghost was built by the private firm Firefly Aerospace located in Cedar Park, Texas. The mission received funding from NASA through their commercial Lunar Payload Services Program and transports 10 novel scientific instruments that have already started investigating the moon. On March 2nd, Blue Ghost initiated its final approach toward the lunar surface. This occurred following a deliberate, methodical voyage from Earth that required over a month to finish. Blue Ghost launched in early January aboard a Falcon 9 rocket. It completed 25 days in Earth orbit conducting system verifications. It traveled for 4 days to reach lunar orbit, where it dedicated another 16 days gradually pinpointing the ideal touchdown location. Blue Ghost entered its landing phase targeting the Mare Crisium region, which lies northeast on the moon's Earth-facing side. As the lander descended toward the surface, it employed an AI-powered computer vision terrain navigation system to establish the lander's location and recognize the best landing area. Once the lander starts its powered landing phase, it functions in a completely autonomous mode. The ground team placed their confidence in the lander to execute what it was engineered to accomplish. Blue Ghost's navigation system continuously monitors craters, slopes, and boulders to choose a danger-free parking location within the landing zone, and that navigation system functioned perfectly. Firefly has declared themselves the first commercial enterprise in history to accomplish a completely successful lunar landing. They must be somewhat cautious with that phrasing because Intuitive Machines is another private American company that reached the moon last year. They asserted the distinction for themselves of the first commercial soft landing on the moon, which holds true in that they didn't crash into the moon at extreme velocity like numerous others have done previously, but they still made contact forcefully enough to break off the leg of their vehicle, which then wound up completely on its back and essentially failed to accomplish most of the scientific work that had been planned. In any case, here's what Blue Ghost is accomplishing on the moon. With a maximum payload capacity to the surface of 150 kilograms, the lander has been equipped with 10 NASA-sponsored instruments, my preferred one being the Lunar Vacuum. Lunar Planet Vac is engineered to collect dusty regolith samples from beneath the lander. Another particularly impressive experiment is one that operated as the lander was making contact. This is the stereo cameras for lunar plume surface studies. It's capturing photographs of the debris that was displaced by the spacecraft's landing engines to quantify how much material becomes airborne and how it acts once it's been scattered. Lunar dust is extremely fine, extremely light, and it travels through an environment without air and with comparatively minimal gravity. So once it gains momentum, there isn't much that will decelerate it. That could present a substantial challenge. And we're concerned that if we displace excessive dust by working on the moon, we might initiate some form of perpetual dust storm. Regarding that dust, Blue Ghost carries a novel instrument designated the Electrodynamic Dust Shield. It's intended to prevent accumulation on equipment by utilizing electrical charges to repel the dust particles. This technology will prove essential if we aim to construct things like permanent solar panels, windows, or heat radiators on the moon. It can prove highly beneficial for protecting the abrasive dust from an astronaut's faceplate as they investigate the moon as well, something that posed a significant challenge for the Apollo astronauts. This is the next-generation lunar reflector. It's going to assist us in measuring the gap between the Earth and the moon with sub-millimeter precision. Essentially, they're going to utilize this small mirror to bounce a laser signal back to a receiving facility on Earth. The Lunar Instrument 4. Subsurface Thermal Exploration with Rapidity is an exceptionally long designation for a drill that's going to bore 2 to 3 meters into the ground to demonstrate how heat transfers through conductive materials beneath the moon's surface and the temperature variations between different depths. Then we have the Lunar Magnetotelluric Sounder. This is positioned at the summit of a mast that projects from the top of the lander. It's actually going to measure the activity deep within the lunar mantle, specifically 2/3 of the distance down to the moon's core. Then after all of that research is completed over the span of 14 Earth days, Blue Ghost will record images of the lunar sunset, giving special focus to how the lunar regolith responds to shifts in sunlight. And then the lander will continue functioning for several hours in darkness until its power cells ultimately expire. If that wasn't sufficient, A second American commercial lander will attempt a moon landing this week. Intuitive Machines has returned for round 2 with their redesigned and enhanced Nova-C landing platform. That's the identical one from last year with the damaged leg. But this time, Intuitive Machines states that they have implemented a broad range of modifications to the lander to enhance last year's unfortunate outcome. The company asserts that improvements in both software and hardware will produce 20 times superior landing accuracy on their second endeavor. Intuitive Machines Mission 2 has been designated Athena. It launched successfully on a SpaceX Falcon 9 last week and is projected to commence descent to the lunar surface on Thursday, March 6th. Athena is aiming for a landing zone on the Moon's South Pole region. Proceeding to the instruments, Athena has been fitted with the Trident drill, which was engineered for NASA by Honeybee Robotics. Trident is going to have the capability to drill as deep as 1 meter beneath the surface by employing a rotary percussive technique, essentially a hammer drill. As the bit is withdrawn from the ground, it's going to extract soil samples, which will then be examined by a mass spectrometer called M-SOLO. This spectrometer will identify the chemical composition of the soil samples, searching specifically for particular minerals and indications of water. Athena will also release a small rover onto the Moon. This is Moon Ranger, developed by Lunar Outpost. It's a 4-wheeled vehicle measuring less than 2 feet in length and height, weighing between 5 and 10 kilograms with the capability to transport up to 15 kilograms of payload and travel at a velocity of 10 centimeters per second. This rover features a near-field depth camera. It's essentially going to generate a 3-dimensional scan of the lunar terrain that can be utilized to build a precisely accurate virtual reality simulation of the Moon for future astronauts to practice in. Riding on the rear of the Moon Ranger rover will be a secondary micro-rover, the Astro-Ant. Developed at MIT, Astro-Ant is compact enough to rest in the palm of your hand and is conceived to be deployed in swarms of multiple rovers that can be employed for spacecraft diagnostics and maintenance. This individual unit test rover will navigate around on the back of Moon Ranger using magnetic wheels, and it will record the temperature of the radiator from various positions, which will assist in monitoring the operation of the larger rover's thermal system. Then there's Micronova, a rocket-propelled miniaturized variant of the Athena lander created by Intuitive Machines that will operate as a hopper vehicle. It's essentially a 2.5-foot cube with landing gear and a rocket motor. It can transport 1 kilogram of payload across a distance exceeding 2.5 kilometers. Micronova is capable of hopping up to 5 times on a single mission, and this will permit access to locations that would be too hazardous for the main lander to venture into. For instance, Intuitive Machines believes that Micronova can become the first vehicle to explore subsurface lava tubes on the Moon. We know that Micronova will be hopping into the depths of permanently shadowed craters, where it's theorized that water ice will be discovered. While in flight, the hopper will employ 2 high-resolution cameras to photograph the lunar surface. It's also equipped with a spectrometer for detecting subsurface hydrogen and a radiometer to record the surface temperature. Both Micronova and Moon Ranger will be communicating with the Athena lander utilizing a mobile 4G LTE communication network, which is supplied by Nokia. Yes, they still exist, and they're heading to the Moon. This will mark the first time that a non-radio-based communication will be implemented on the Moon, which should facilitate the command and control of vehicles from Earth and high-definition video transmission from the lunar surface. Changing topics here to SpaceX. We had been expecting another Starship launch this week. On Monday evening, the mission was then canceled at T-minus 40 seconds on the countdown timer. At the time, SpaceX didn't offer many specifics on the cause, but later Elon Musk provided some clarification by posting on X, quote, "Too many question marks about this flight. And then we were 20 bar lower on ground spin start pressure. Best to destack, inspect both stages, and try again in a day or 2. What he's referring to here is the pressurized gas that accelerates the fuel turbo pumps on the Super Heavy Booster's Raptor engines. That pressurized gas originates from a ground system that's incorporated into the launch mount. As of Tuesday, Starship remains completely stacked on the launch tower, and SpaceX has adjusted the launch time to Wednesday, March 5th, at 5:30 p.m. U.S. Central Time. In case you missed it, Elon was recently discussing Starship on the Joe Rogan podcast. There was a positive news and negative news situation here. Elon made a somewhat disappointing revelation that Starship's long-anticipated in-flight refueling demonstration will be delayed to next year. This would be a mission where 2 Starship upper stages would rendezvous in low Earth orbit. connect together in a back-to-back arrangement, and then transfer cryogenic liquid propellant between the two. This was one of the major milestones that SpaceX had discussed achieving in 2025, but now even Musk is apparently not believing that this will be feasible. He somewhat explains the reasoning as being that complete rapid reusability of the ship stage must come first before the propellant transfer can make practical sense, meaning that the ship must re-enter the atmosphere without damage and successfully return to the launch site for a tower capture. This is something that Elon does believe will occur this year. He informed Joe there is a strong possibility of achieving full reusability of Starship this year, but with the qualification that an immediate return to flight, meaning the rocket returns, gets captured, gets positioned back on the launch mount, refueled, and then relaunched, that won't be occurring until at least next year as well.